Alright, so in this mini-series we're going to talk about fraction operations. In this video we're going to focus on just adding and subtracting fractions. So rational operations is what they're called. Just remember, rational numbers, fancy word for fractions. So we're going to talk about adding, subtracting, and technically comparing fractions. Although I'm not really going to do any examples of comparing fractions, but the rules are the same. When adding and subtracting, you need like denominators. And we'll talk about multiplying and dividing in another video. So we're going to talk about adding and subtracting and comparing fractions. Alright, so what you need to know is this. When adding or subtracting fractions that already have like denominators, you have almost no work to do. Here's what you always do. Anytime you add or subtract, once you have like denominators, remember, vocabulary, denominators is the number on bottom and numerators is the number on top, so make sure you know which one's which. Okay? Once you already have the same number on the bottom, when you add and subtract, that number on the bottom stays the same. So it's going to be an 8 for that example. And then you just add the top. And so you always just go straight across the top. So 3 plus 3, well, that's 6. So you have 6 over 8. That is your answer. The only problem is that fraction simplifies. It's not in simplest form. So what goes into 6 and 8? Well, 2 goes into 6 and 8. So I'm going to write little divided by 2 to remind me, or you as a viewer, what we simplify by. So that gives us, we end up with 3 over 4. And now it does not simplify any further. So 3 over 4 is our final answer. That's the answer to number 1, 3/4. Okay, so for each of these, you do it to the top, and then you keep the bottom, do it to the top, and remember to simplify fully. So take a moment to try number 2. Hit pause. You get 2 over 10, and then we're going to simplify by dividing top and bottom by 2, and if we do that, we'll get 1 over 5. So the answer to that number 2 is 1/5. All right, so I think you're starting to get the hang of this. So we'll do maybe one more together. I'll do one more for you. Then I want you to go ahead and try any of the others you want to try, and I'll show all the answers. Go ahead and do. Let's do one with negatives. Let's come down here and do number 12. Come down here and do number 12. Press pause and give it a shot. Well, you know the denominator is going to be a 9. Now, if you're dealing with these, go ahead and just pretend the negative is up top, if that helps. Pretend it's the 5 that's negative. So think of this as -5 plus 7. So you're going to use your negative number skills. And if you need help with that, check out the video I have posted on integer operations, and I also have another video just on adding and subtracting with integers. Well, -5 plus 7, you're going to go to the right from -5, so you're going to pass 0, you're going to end up at positive 2. So -5 plus 7 is positive 2. Another way to think of that is 7 minus 5. That's positive 2. And 2 over 9 does not simplify. So that's your final answer. That's number 12. Alright, so here's what I'm going to do. If you want to try more of these questions, great, hit pause. What I'm going to do is I'm going to show the answers to all of them, and I'll even try to show as much of the work as I can fit, but I'm going to hit pause and I'm going to show them all. So if you'd like to try a few more of these for more practice, make sure you know you've got it and you're simplifying all the way, go ahead and do so. Otherwise, you can go past that point if you're ready to do it unlike denominators. For starters, we know all the denominators are going to be that. So now go ahead and do it to the top and then simplify all the way. So now once you do the top, you go to each of them to see if they can be simplified. So starting with, I'll look at number 4 first. Number 4 cannot be simplified, and you know that because 7 is a prime number, meaning nothing goes into 7. So the answer to number 4 is 2 over 7. Now the same thing goes for number 7. Because 7 is a prime number and 7 does not go into 15, that means that fraction does not simplify any further. So that's our final answer for that one as well. So that was our final answer. Now the rest of them looks like they might simplify or somehow convert in simplest form. So for example, take a look at number 3, take a look at 5, see if any others do it. Have the bigger number on top. Okay, it looks like those are the only ones. If the bigger number is on top, that's called an improper fraction. And so literally its name implies it's not proper. An improper fraction, we don't want to leave it that way because it's not fully correct to communicate your final answer. Now, I agree that if this was a question where you had more math to do, you had more things you needed to end up doing, then yeah, I would leave those as improper fractions for now. But if it's your final answer, your final answer, go ahead and put it into a mixed number. So a reminder how to turn things into mixed numbers. The way you do it is this. You ask yourself, how many times does the bottom number go into the top number? So 3 goes into 4 one time, and then you put it in. Then you put the remainder. The remainder becomes the numerator. So it's becoming a mixed number. So 3 goes into 4 one time with a remainder of 1, and then the denominator stays the same. It's a 3. So 1 and 1/3. So again, 3 goes into 4 one time with a remainder of 1. So the how many times it goes into it is the big number. The remainder is the little number up top, and then the denominator stays the same. And then if this part simplifies, you would go even further and simplify. So 1 and 1/3, that's a mixed number. And mixed numbers get their name because they are a mixture of numbers. They have a whole number and they have a fraction. So it's technically 1 plus 1/3. So it's a mixture of two types of numbers. So they kind of get their name. That's why we call them mixed numbers. Okay, so now the other one. 10 goes into 12 one time. I'm going to do it right below it. 10 goes into 12 one time with a remainder of 2. So it's 1 and 2/10. Well, 1 and 2/10, that simplifies. The 2/10 simplifies. This is an example of what I meant where you could do this. Now, technically, if you had simplified it here and you divided top and bottom by 2, you would have already had 6/5, and you then would have turned that to the same answer. But if you didn't do that, that's okay. So 1 and 2/10 simplifies to 1 and 2/10. 2 goes into both of those, so it becomes 1 and 1/5, which would have been the same answer if you had turned this one. Oop, didn't mean to go change screens. If you change this one to 6/5, you would then still change that to 1 and 1/5. They both turn into that. So your final answer is 1 and 1/5 to number 3. That's our final answer. Okay, so skimming through the rest of them, seeing if they simplify. Number 6, 3/9 simplifies to 1/3, and that's our final answer to number 6. Number 9, 4/10. 2 goes into both of those, so that turns into 2/5. And that's our final answer for number 9. And I'm going to go ahead and fill in the rest of them. Alright, I circled all the final answers in green. Okay, now let's do some examples where we do not have like denominators. Feel free to write any of these down that you think that you need to help you remember. So adding, subtracting fractions, when you have like denominators, just go straight across. The bottom stays the same, and then you only do it to the tops. So when adding, subtracting unlike fractions, meaning unlike denominators, the first step is convert them to common denominators. So that's what we're going to talk about. And then your second step is it's now a like fraction question. So if it's just like the other questions, that means you're going to keep the bottom, aka the denominator, and you're just going to do it to the tops or the numerators. And after that, just simplify your final answers. So that's what we're going to do now. So in each of these examples, we have denominators. The number on the bottom is different. So that's the first thing we're going to do. We're going to talk about how to find like denominators. So to find like denominators, you're asking yourself, what do they both go into? Not what goes into them. What do they go into? What do they both go into? So in other words, we're looking for common multiples. And technically, we're looking for the least common multiple. That's ideal, but it doesn't have to be the smallest one. So I'm using fancy vocabulary. Essentially what I'm saying is, what number does 12 and 10 both go into? That's what I'm asking. So one way to always find a common denominator, I'm not saying it'll be your least, but it'll always at least find a common denominator, is multiply them together. 12 times 10. So that means 120 is at least a guaranteed common denominator for this question. So you would do that. You would start getting set up. But here's the thing. It's not your least common denominator, so it's going to require you to do more work. Because technically 12 and 10 both also go into 60. They both go into 60. So in this case, multiplying them together wasn't your least common denominator, but it was a common denominator. So I'm going to recommend putting them into the least if you know what it is. If you don't, it's okay. It's not the end of the world. So I'm going to convert them to they both have a bottom number of 60. Because they both go into 60. So let's see, the way you convert these. You know that to get to 60, you multiply 12. That's not time symbol. You multiply 12 by 5. And so if you do it to the bottom, you must also do it to the top. So if you multiply 12 by 5 to get it to 60, you got to multiply 5 by 5 to get it to 25. So that left fraction turns into 25 over 60. So 25 over 60 is equivalent to 5 over 12. Now we're going to do the same thing for the second one. To get 10 to 60, we're going to multiply it by 6. If you do it to the bottom, you have to do it to the top as well. And so 3 times 6 is 18. So that means we have 25 over 60 minus 18 over 60. And so our job now is to now do what we said in our steps. Now keep the bottom, keep the denominator the same, and now just do it to the tops and then simplify your final answers. So 25 minus 18, well that's 17. So we have 17 over 60. And you ask yourself, the 17 over 60, I said 7, not 17. Don't know why I wrote that. Let's try that again. 7 over 60. So, unfortunately, 7 is a prime number. Nothing goes into 7. And 7 does not go into 60. Therefore, you're done. That's your final answer for number 11. That is your fully simplified answer, 7 over 60. Now let's take a look at number 12. Sometimes your common denominator is one of your denominators already. If you look at 9, 9 goes into 9, but so does 3. So really, we just have to turn 3 into a 9. Looks like I drew a smiley face. And then you're going to be okay. So you only have to convert one of them in this case. So to turn 3 into 9, you would multiply by 3. Well, if you do it to the bottom, you have to do it to the top. So that's gonna turn into, we're going to have 7 over 9 stays as 7 over 9, plus 2 times 3 is 6, so that's going to be 6 over 9. Oops, sorry, I didn't mean to change pages on you. So that's going to be 6 over 9. So we have 7 over 9 plus 6 over 9. Now, keep the bottom, so the bottom is going to be 9. And now just add the top. 7 plus 6, well, that's 13. 13 over 9. Now, fraction does not necessarily reduce, it doesn't simplify, but it does convert to a mixed number, because that's an improper fraction. 9 goes into 13 one time with the remainder of 4, so it's 1 4/9. And that is our final answer to number 12. So for 13 and 14, I'll go ahead and hit pause and give those a shot. I'll write down the answers for you so you can check yourselves. Give those a shot. Hit pause. All right, there are your answers for 13 and 14. Make sure you understand how to get those answers. So now we're going to do a few more, but I'm going to zoom in and make these a little bit easier because I know it's kind of hard when you see all these on the screen at once. It starts to get kind of overwhelming. So we're going to start to zoom in and do some of these a little bit more at a time. Alright, so let's take a look at this example. And in this example, we're also going to be combining our negative skills. And again, if you need help with your negative skills, look at the videos. I have a video just on integer operations, and I have a video specifically on adding and subtracting with integers. And that's what you would use for this. So the first thing I'm going to do is I'm going to use our negative skills to rewrite this in an easier way. I'm just going to reconvert this to something that makes a little more sense. In other words, what happens when you minus a negative? When you minus a negative, we learned, they both it turns into plusing a positive. So you're really just adding a positive. So I'm just going to rewrite this to what it really is. So this is really 3 over 4 plus 1 over 2. That's what this is really saying. 3/4 plus 1/2. That's what we're doing. Okay, so let's now convert these to common denominators first. In this case, they both can turn into a 4. So the one on the left doesn't change, but on the right, we're going to multiply top and bottom by 2 so that it does change. So if we do that, we have 3 over 4 plus 1 times 2 is 2, 2 times 2 is 4. So 3 over 4 plus 2 over 4. We're now ready to rock and roll and do step 2. Keep the bottom, but then we're going to do it to the tops only. So the bottom is 4 and the top is a 5. So we have 5 over 4. That is our answer. It's just not a fully simplified proper fraction. So 4 goes into 5 one time with a remainder of 1. So it's 1 1/4, and that's our final answer to that question. Make sure you understand what we did there. Alright, so if you think you understand this example, let's give this one a shot. Hit pause and try this one. But I'll make it easy on you. If you think that it's going to be too hard having that negative right there, we can cover that negative up. But I would like for you to try to do it with a negative so you can combine your negative skills. Because I want you to know fractions can be negative. Alright, but hit pause and give this one a shot. So if you convert to common denominators, you could just do 6. You could just do 6 times 4. 6 times 4 will give you 24. So you could have 24s down here, and that is a common denominator. And you could do that. It just wouldn't be your least common denominator. So you'd have bigger numbers. You'd have more work to do. So the smallest thing that 6 and 4 both go into is 12. So you multiply the left side fraction top and bottom by 2, and the right side top and bottom by 3, since 4 goes into 12 3 times. Now you have your common denominators. You're ready to rock and roll. So you have, treat this like your negative skills. You have negative 10 plus 3. Remember, we're going to keep the bottom. So the bottom is going to be a 12. And up top, negative 10 plus 3. That means you're adding, so you're going to the right. So from negative 10 going to the right, you're heading towards 0. So that's going to be negative 7. So you have negative 7 over 12. Negative 7 over 12 does not simplify. So your answer to this question is that negative sign. You can keep it up top if you want, or you can just put it in the front. It doesn't matter. It means the same thing. Negative 7 over 12. That is our final answer to this question. And as a note, if this had been a positive 5 over 6, like if I erased that negative sign, we would have gotten 13 over 12, and 13 over 12 would have simplified to 1 1/12 if you had done it that way, if I said pretend it wasn't negative. But when it is negative, your answer is going to be a little different. So make sure you're understanding what's going on here. This was another example of adding and subtracting with unlike denominators. Alright, so I've got two more examples on the screen. I want you to give these a shot on your own and give them a try and hit pause, and then I'm going to reveal the answers and the steps for both of them. Okay, so hit pause, at least for number 17. I'll do one, then the other. So first things first, minusing a negative really just becomes plusing a positive, so this becomes just plus. Converting to common denominators, you should have negative 8 over 12 plus 9 over 12. So if you had trouble from getting to this step, or maybe you had something different, go ahead and hit pause and finish from here if you haven't done so already. Alright, so we're ready to finish. Negative 8 plus 9. Negative 8 plus 9 is 1. It's positive 1. And our bottom is still 12. So the answer to this question is 1 over 12. I don't know why I put it all the way over there. I was thinking there'd be more work. So we're done with that one. Now, number 19. Hit pause and try that one if you haven't done so already. Convert them both to having common denominators. Negative on the bottom stays the same, so we have over 20. On the top, negative 6 plus 5. Negative 6 plus 5 is negative 1. So negative 1. You can write it like that, or technically you could have the negative up there if you wanted to. One or the other, they mean the same thing. Not both, one or the other. So the answer is negative 1 over 20, and that's our final answer to number 19. Make sure you copy these down. Alright, so we're going to make these our last two examples. So in this one, you're going to, same thing, you're going to try both these on your own just to make sure, and these are going to make these our last two examples. And then you'll be all done. And then we'll do a brief recap and we're all done. Alright, so try number 18 or 20. Go ahead and try both, and I'll reveal the answers for them. Hit pause. Number 18, we get 20, we common denominator, and then we get 23 over 24. That does not simplify, so that is our final answer. Hit pause, try number 20 if you haven't done so already. Okay, we end up with 7 over 12 plus 4 over 12. 7 plus 4 is 11, so we have 11 over 12. And 11 over 12 does not simplify, so that is our final answer for number 20. Alright guys, so brief recap. In this video we talked about adding and subtracting unlike fractions. Okay, that's what this video was about. We started off talking about like denominators. And by the way, we point out you must make them common denominators when adding and subtracting or comparing. So we talked about how to find common denominators, but in these examples we already had common denominators, so that step was done. So we were able to focus just on doing it on this one. And then we talked about the steps, what to do when you have unlike denominators. You're going to convert them to common denominators, and then you're going to, when you do that, you're going to ask yourself, what do they both go into? And now once you do that, you keep the bottom number just like you did for these examples, and you just do it to the tops, and then simplify your final answer. We then did a variety of examples for each of those. And then you're able to check yourself. So make sure that you now have a variety of examples helping yourself with adding, subtracting, unlike fractions. Make sure you always feel all fractions, I promise you, even if they're fancy algebraic fractions in Algebra 1 or Algebra 2, all fractions are rational expressions and equations. I'm using big words, but you'll do this in the future. They all follow these rules. When you add and subtract, you must have common denominators. All right, take care, guys. Good luck.